Kotlin Multiplatform allows you to build both iOS and Android apps while sharing a codebase. That means faster development, lower development costs, and native app performance. We heard about this about a few years ago, and our Android team came up with the idea of testing it. First, we migrated a few of our internal projects to test out the framework and understand how it fits into our development processes. And the initial results looked very promising. After gaining confidence from those projects, we started introducing Kotlin Multiplatform into client projects as well. To date, we have completely migrated more than 10 projects from native to Kotlin Multiplatform. And in this video, I'll walk you through our experience of migrating a native Android app to Kotlin Multiplatform. I'll show you what worked well, what challenges we faced during the migration, what improvements we saw afterwards, and most importantly, whether the actual business cases actually made sense for KMP. And one more thing, at the end of this video, I'll share something that can be incredibly helpful if you're considering to migrate your existing app to Kotlin Multiplatform, so make sure to stay here until the end. So, let's get started. I'm Alexa, CTO and co-founder at Aetherius. We build mobile apps, and over the past few years, Kotlin Multiplatform has become a crucial part of our development processes. If you're already familiar with KMP, feel free to skip this part. I'll quickly cover the basics for everyone else. Kotlin Multiplatform, or KMP, lets you write shared business logic in Kotlin that compiles and runs on both Android and iOS. You don't write a single code base that's shared across both platforms as you do like with Compose Multiplatform, Flutter, or React Native. So with Kotlin Multiplatform, the UI stays native on both platforms. Here, you only share the business logic of the app, such as networking, data models, repositories, and validation rules. The benefits are clear: fewer bugs caused by platform differences, features that ship simultaneously on Android and iOS, and the ability to move faster with a smaller and more efficient team. All of these benefits can have a significant impact on development costs, which is exactly why more and more enterprises are getting interested into Kotlin Multiplatform. Now that you know a little bit more about KMP, let me walk you through our migration journey and what we learned from it. But let's start with the hard stuff first. Our initial migrations didn't go smoothly. We faced different problems, and one of them was with Kotlin coroutines. Kotlin coroutines are a part of almost every modern Android project, so naturally, we didn't expect them to become one of our biggest challenges during migration. We were wrong. Back then, Kotlin Native was still using its old memory model, which had strict rules around sharing mutable state across threads. As soon as coroutines started switching threads on iOS, we began seeing issues that we had never encountered on Android before. We ran into object freezing, thread crashes, race conditions. And the most frustrating part was that many of these issues appeared only on physical iOS devices. Everything looked fine in the simulator, but the app would behave completely differently once it was running on a real device. We spent almost 3 weeks debugging this because at first nothing pointed directly to coroutines. The same code worked perfectly on Android, and even on iOS it would sometimes work and sometimes crash depending on how threads were scheduled. Eventually, we realized that we could not simply take our Android asynchronous code and expect it to work the same way on iOS. We had to rethink how our shared state was addressed, carefully wrap coroutine calls, and redesign several asynchronous flows entirely. The good news for all of you is that this is much less of an issue today. The new Kotlin native memory model has removed many of the old limitations. Also, the libraries like Skia and KMP native coroutines make interoperability between Kotlin coroutines and Swift's async await significantly better. The second big challenge for us was dependencies. As you know, every project depends on dozens of libraries for networking, databases, analytics, dependency injection, image loading, and many other things. So a few years ago, this was a real problem because many of the libraries Android team relied on were never designed to run outside of the JVM. They often depended on Java classes or Android specific APIs, which meant they couldn't simply be reused in the shared code. Since shared code also has to run on iOS through Kotlin Native, those libraries could not simply be moved into the common code. So we ended up reviewing every library we were using in order to figure out if it could be replaced with a KMP alternative if we needed a separate implementations for Android and iOS, or if it simply made more sense to keep the library native. Just like with coroutines, the KMP ecosystem has significantly evolved, and dependency compatibility is no longer the major pain point it was a few years ago. Today, the situation is completely different. There is a much larger ecosystem of the libraries which are compatible with Kotlin Multiplatform. So, libraries like Cater for networking, SQL Delight for databases, Coin for dependency injection, and many others can now be used directly into the shared code. And if you're evaluating a migration, finding compatible libraries is much easier than it used to be. You can explore the official list of recommended Kotlin multi-platform libraries on the Android developers website and browse hundreds of community supported libraries on klabs.io. Once the migration was complete, we started seeing some really interesting results. Have you ever noticed that some of the apps behave slightly differently on Android and iOS? Maybe a feature works one way on Android and other way on iOS, or a new feature appears on one platform weeks before it arrives on the other. In many cases, that's the result of something called logic drift. Logic drift happens when the same business logic is implemented separately for Android and iOS and then evolves differently over time. Most users don't notice this in older features, but it's quite common to see new features being released on one platform before the other or to encounter slightly different behavior between Android and iOS. With Kotlin Multiplatform, this becomes much less of a problem because both platforms use the same shared business logic. When Android and iOS use different implementations for same feature, you often end up with different bugs on each platform. By sharing the business logic, we were able to reduce the inconsistencies significantly. Across the projects we tracked, cross platform bugs dropped by more than a half during the first year after migration. QA cycles also become shorter because the same logic no longer had to be tested separately in two different codebases. One of the things that really impressed me was that you don't have to wait until the entire app is migrated to start seeing benefits of Kotlin multiplatform. Even before the migration is complete, you can start putting new features into shared modules and reuse that logic on iOS. From that point on, new API integrations, data transformations, and business rules only need to be built once and tested once. For apps that handle a lot of data, that can save a significant amount of development time. With Kotlin Multiplatform, maintenance becomes much simpler. In native projects, fixing a bug often means implementing the same fix twice, reviewing it twice, and testing it twice. With KMP, many issues only need to be fixed once in the shared layer. This reduced duplicated work and made ongoing maintenance more predictable. Over the time, this became one of the biggest advantages, especially on projects that had already been in production for several years. So, would I migrate every single mobile app to Kotlin multiplatform? No. If you're building a simple MVP and just want to launch as quickly as possible, there are easier ways to do it. Kotlin multiplatform makes the most sense when your app has a lot of business logic, you expect it to grow over time, and your team is already comfortable with Kotlin. If you're thinking long term and care about maintainability, reducing duplicate work, and keeping native experience on both platforms, KMP is definitely worth considering. What's going to happen with the iOS team? Well, you still need them. Anyone telling you that Kotlin multiplatform eliminates the need for iOS developers is overselling it. What changes is how they spend their time. Instead of rebuilding the business logic that already exists on Android, they can focus on what really differentiates the iOS app, and that's building great user experiences, leveraging platform specific capabilities, and making sure the app feels truly native on Apple devices. And now, I'd like to show you something we've prepared internally. It's a KMP template that we use at Aetherius as a starting point for almost every new Kotlin multi-platform project. It comes with things like clean architecture with an MVVM, Firebase integration for database and storage, and a reusable UI system for pre-built design system, and many other integrations that we use in our own projects to get started much faster. If you're getting started with Kotlin Multiplatform, I think you'll find it really useful. I'll leave a link in the description for anyone who wants to download it and explore it for themselves. That's all for today. I hope you find this video useful, and if you did, subscribe to the channel to support our work and help us continue creating content like this. Thank you very much for watching, and see you in the next video.